All right. Hello, everyone. So we're probably going to get started with the Aptomi. So my name is Roman. I'm one of the guys behind the project and one of the core contributors. So what we're going to talk about today, we're going to talk about some of the use cases that we see on top of Kubernetes, right, and how people run their apps. And we are going to talk about Aptomi, which is the application delivery engine for Kubernetes, which is completely open source. And we're going to go through the live demo with stuff deploying to Kubernetes and showing some rules and things like that. So I'm going to try to spend a very small amount of time on the slides just to explain what the problem is that we're trying to solve and explain the demo setup. And I'm hoping that the rest we can just do the live demo. So before I start, let me ask a question. How many of you guys know about Kubernetes and Helm? OK, so roughly half of the people. I think that's good. So I think let's get started. So first of all, let's take a look at the problem that we are trying to solve. And we're just considering the container-based applications, right, and how you build and how you deliver those. And when we talked to a number of people and a number of customers, and we looked at the CI, and CI seems to be a solved problem, more or less, right? I mean, you take Jenkins, so everything that starts with your source code, and then your Docker files, all the way to building and testing your component and publishing this binary to a repo somewhere. This part, for the most part, is a solved problem. The problem comes later, like the big problem comes later when you are talking about the CD, right, about delivering applications built out of those components. And right now we're talking about container-based applications which run on top of Kubernetes. Right, and typically you will see something like this. So at the very bottom level, you're going to have Kubernetes, which gives you container orchestration. On top of that, you have Helm, right? So you have application consisting of multiple Helm charts or Kubernetes manifests and a number of containers, right? We have a number of those pieces. And then on the top of that, you have some sort of delivery pipelines, right? So you saw Spinnaker in the previous presentation. You can have Concourse, you can have Jenkins pipelines, you can have Go CD. It's a matter of your preference, right? Whether you want this functionality or that, whether you want YAML or Groovy, and things like that. So that's the typical stack that you will see today, right? Container orchestration, component building blocks, and delivery pipelines and workflows. So what is the problem, right? So the problem is when you start building things in this way, you have to deal with a lot of level primitives on the Helm side and on the Kubernetes side, right, with the Kubernetes object model and things like that. So what actually happens is when you're putting applications together, you want to reason about applications and services, right? You basically want to say, I have this service from 5 or 10 or 15, and we've seen cases with 50 components, right? And I want to run this service in this environment, and I want my production to be secure, and things like that. So you want to reason about applications and services, but if under the hood you have this lower level primitives, right, with Helm and Kubernetes YAML files, you end up doing a lot of work, right? It's a lot of templating, a lot of YAML files. Things are not very clear and crisp, so your life becomes pretty hard. And our thought was, OK, like what if we can introduce the notion of a service to the picture, right? So you don't have to deal with a bunch of containers and YAML files. Then you can use this light abstraction of services, and then you can reason about services and rules around those services. So that's a very simple idea. And just to illustrate that case a little bit, right, about the complexity which stacks up when you're dealing with the existing tooling, and if you are taking the single chart, your life is easy, right? You just do the Helm install, one component done. When you are doing some basic service composition, when you're starting to do some basic service composition, like maybe like 2 services sharing a database, then the life becomes a little bit harder, right? Because you have to run those charts, you have to connect them, components need to know where the other components are to talk to them. It's a little bit harder. when you are talking about more complex applications, then the life becomes really hard, right? Because you have to bring up more Helm charts, connect them together, and propagate parameters, make sure configuration is consistent. When you change something, maybe it has to be changed in some other place as well. So this is hard. And finally, when you start getting into more complicated cases with the service composition, right? You have more complex apps, you have service sharing, you have to run things across multiple environments and multiple clusters. That's where the life becomes really, really difficult, right? So it's just to illustrate the point and the problem that we're tackling. So our idea was really simple, right? So we're basically saying there seems to be a layer missing, right? I mean, maybe some people don't need this layer. The people who are dealing with just individual components and they don't have a lot of complexity, right, with the application delivery. But we found that for a lot of people, actually the complexity is there. So our thought was, what if we can introduce this lightweight layer built on the top of all the community abstractions, right, on the top of Helm, to deal with this problem, right? To allow you to compose services, allow you to run those services across multiple environments, multiple clusters with different settings. And this layer would allow you to focus on services and the rules around those services, right? So you can basically say like, hey, all my dev stuff gets deployed to one place. All my production stuff gets deployed to another place. Or all my, I don't know, like Kafka instances in stage, they have those characteristics, like, I mean, the rules around those. So this is the basic idea. Any questions so far before we go into the demo use case? Cool, I think it's pretty clear. OK, so just a couple of words about this demo setup so that you guys know what we're going to be showing, right? So what I'm going to be showing, and then we can switch to the live demo. So the use case that we are trying to show, the end-to-end use case, is an application that grabs data from Twitter streaming API, does the processing, right, calculates the top hashtags, and displays results on the web page. And how it's done under the hood, it's done with two services. So you have one service called Analytics Pipeline, which is defined in this demo. So this service, we're basically saying, hey, maybe you have a platform team in your organization, right? They're responsible for running that service with the Kafka, Spark, HDFS, and Zookeeper. They know how to run it, and they're experts in how those components should be put together. And then you have another service which is called Twitter Stats with three components, right? There is a publisher, which grabs data from Twitter. There is this job thing, which basically does calculation of the hashtags using that external service. And there's a visualization part, which displays results on the web. So all those blocks, this like light blue blocks that you see, they correspond to individual Helm charts that we're going to be using during this demo. So basically, this is the use case. This is the definition of services. And now let's talk about how we're going to run them, right? In which clusters and what's going to be the setup. So the setup that I'm going to demonstrate is going to be this, right? So basically, we have two Kubernetes clusters, US West and the US East. And we could have used 3 clusters for this demo, but for simplicity, we use 2. There is nothing that prevents you from using 3, 4, 5 clusters. And what we've done is that we basically define a rule saying that the analytics service is going to be a shared service that is going to be used by all analytics consumers. And the service is going to be maintained by a platform team. It's going to run in the cluster US East. And we're also going to have a production version of the Twitter stats that pulls data off Twitter streaming API. This is going to run in the cluster US East as well, but we could have used a third cluster for this, no problem. And we're basically saying, in addition to this, let's say that we also have dev instances of Twitter stats, which are not going to be using the real Twitter streaming API. They're going to be using like a fake generator of tweets. We're going to direct them to another cluster. And they're going to be relying on the same analytics pipeline running in the cluster US East, right? So this is the simple setup. So this is something that shows you how you can run application, right, consisting of multiple components connected together across multiple environments, multiple clusters. I believe in your organization you may have, obviously different use cases, how you run services, how you decompose them, how you connect them together, but this is the case that we're going to focus on in this particular demo. So I think at this point we're ready to move on to the live part. And just before we move to that, I just want to say that if you are trying to deal with this today, right, if you're trying to use the existing tooling to achieve something like this today, right, just relying on Helm and Kubernetes YAML files, the life is super hard, right? I'm not going to go into details why, but it's really, really difficult. So, and the live demo, basically what I'm going to show, first of all, I'm going to show this service abstraction layer, right, the Aptomi itself, that allows you to run services and manage environments and rules and services as code. And then on top of that, I'm going to show how this would fit into your existing CD workflow, right, whether you're using Spinnaker or Jenkins pipelines, anything. So for this particular demo, we picked Concourse because it's not as bulky as some of the other tools. It's very lightweight. Everything is code, read-only UI, and then you define everything from CLI or GitOps from the YAML files. So that's going to be, so that's the preparation part. So at this point, I think we're going to go to the live demo. And before I start, let me show you a couple of things. So we're starting completely from scratch. There are 2 Kubernetes clusters. They're completely empty. So I'm going to have a watch here. So if you guys think I should make it bigger, maybe like raise your hand. I can increase the font. OK, cool. So probably this is good enough. Cool. More? OK, let's do more. We can do a little bit more. Cool. OK, so let's get started. So the first thing I'm going to do, I'm going to start Aptomi. So Aptomi is written in Go. It's very simple. There is just a server and the client, right? So like you have kubectl, you have aptomictl. So the first thing I'm going to do, I'm going to type aptomi server to run this locally. Make font a little bigger. So I have a server running right now. And then here in a separate tab, I'm going to run the client. So if I, for example, say aptomictl version, it's going to show me the version of the client and the version of the server. So we're kind of ready to go. So once you run the server, you can also access the user interface of Aptomi. I can log out right now. So this is the first thing that you see if you start from our Git repo and the community version. So you log in with the predefined admin user, and the first thing that you see that everything is empty, right? Because it's just a brand new, fresh installation, and we'll need to import objects into that installation. So the first thing that we need to do, we need to point Aptomi to a number of Kubernetes clusters, right? Because we need to know about the deployment targets, and we need to know about where things should be deployed. So let's do that. So I'm going to use my small cheat sheet, but I'm going to explain every single step. So the first thing that I'm going to do, I'm going to point Aptomi to the file with the Kubernetes clusters, right? Like kubectl, you do aptomictl, apply, and then you feed us with the file where the clusters are defined. Once the changes are applied, then you can go to the user interface, to the clusters page. Let me try to make this a little bit bigger as well. So you can go to the clusters page, and you can see that now Aptomi knows about the Kubernetes clusters, right? We know, OK, there are 2 deployment targets, east and west, that we are going to be using in this demo. If you are wondering about the format of those files, right, it's like what the files are, we can look here. It's basically, it's nothing complicated. What you do is just you feed kubectl into us, as simple as that, right? And once we have kubectl, then we can operate with that cluster. The only thing is that, like with Kubernetes, you have to provide like a object header to us. It basically says kind cluster, name US East, type Kubernetes, because this is pluggable. This can work with more just Kubernetes, but for now, the only default implementation is Kubernetes, and then followed by the kube config. Cool. So now we have 2 clusters in. The next step for us would be to define the services, right? The ones that we talked about, the Twitter stats as well as analytics pipeline. So let's start with analytics pipeline. So same thing as we did with clusters. I'm calling Aptomi CTL, apply, and then the folder where the definition of the analytics pipeline is stored. Now, if I go here, I can see that, OK, we have HDFS, Kafka, Spark, and Zookeeper, all imported into Aptomi. We can also generate the kind of dynamic service graph. And I'm going to show you, let's say, for the analytics pipeline, right? So kind of because Aptomi knows about the relationships between all of different components, you can see that there is this Kafka and Spark. They depend on Zookeeper. And every of those components is implemented with the Helm chart. And there is this umbrella analytics pipeline service, which includes the other 3. So, right, so this picture is dynamically generated. I mean, you can look also HDFS. This is as simple as one Helm chart. And you can look at Kafka, which is Kafka itself, as well as dependency on Zookeeper, right? So this is how you would import that service into Aptomi. So given that we have 23 minutes, I think I'm going to show a little bit of how the services are defined, right? And you'll get the rest, I think. So let's look at Kafka. I'm going to go to services. So the way how the services are defined is actually pretty simple too, because we're building this abstraction on the top of community Helm charts, right? So our goal was to introduce a very, very lightweight abstraction, right? So that you don't have to reinvent a new format for describing applications. You just basically say which Helm charts should be instantiated and what's the dependencies between those. So we basically say, OK, it's a kind service named Kafka. It consists of 2 components. One component is Zookeeper, which is also defined as a separate object. And the other component is Kafka, right? And for Kafka, we basically say it's type Helm. It says repo where the chart should be taken, name of the chart, version of the chart, as well as some of the parameters that you pass. And we also have this concept of discovery. I don't think I'm going to go into that in more details, but basically once you bring the services up, right, you basically Kafka needs to know where the Zookeeper is, right? So then Zookeeper is able to expose, right, where its connection URL through a certain parameter, like Kafka exposes it here, and then Kafka can rely on that parameter, right? So we can basically say zookeeper.url. It's going to be substituted with the real URL when Zookeeper gets instantiated. So Kafka will know where the Zookeeper is. So that's an easy way for us to connect those services. In the real life, you may be using like an external service discovery. Maybe it's going to be API-based. It's up to you how to do this. But for the purpose of this demo, we're going to show this built-in, very simple parameter substitution, right? And that's the way how we're going to glue services together. So now let's do exactly the same, but with the Twitter stats. So apply folder where the Twitter stats service is stored. Doing this, we're going to go here, open the diagram. You can see that it got bigger. You can see those Twitter stats service with those 3 components, right? The publisher, the job, and the visualization. And it depends on the analytics pipeline. And you can also see that the service exists in 2 contexts, right? So there is this real-time context, which corresponds to, let me go back to the slides. So the real-time corresponds to the right part of the picture, right, which pulls data from Twitter. And the other context, the dev, it corresponds to the left part of the picture, which doesn't pull data from Twitter, but pulls it from fake generator. Again, it's a little bit complicated setup, right? But we wanted to show the real case where people are really struggling with service composition and running things across different places and different environments. So the good part is that we're mostly done, right, with the preparation. Now we can actually go and start deploying things. And the only final step that we have to do, we haven't really defined any rules, right, of what goes where. If you remember the slides, there was this east and west. So I'm going to do exactly the same way. I'm going to feed Aptomi with basic rules. Then you open the rules window, right? And you can see that platform services, which is analytics, it basically says, OK, it needs to be deployed to cluster US East, real-time to East, and the dev to West. And this rule we're not going to touch for now. So basically, this is a simple way to define placement of what goes where. So you can, if it was, let's say, your organization, you can basically say, like, all services with this label always get deployed to this cluster, this namespace, things like that. And you can define more complicated rules as well. So now let's go and instantiate a couple of things. So first of all, let's instantiate those two guys, right? This dev1 Alice and dev2 Bob. Let's instantiate the dev instances. So the good thing is that because we already spent time in defining the service graph and those services, right? We don't have to do a lot when we actually instantiate a service. You don't have to feed like a megabytes of YAML files. You basically say, I want Twitter stats. That's the only thing that you tell Aptomi. Based on that, Aptomi goes and actually figures out where the service should be running, right? What components should be instantiated, and so on and so forth. So now you can see that we fed this to Aptomi. So Aptomi is actually saying, OK, here's the action plan, all of those instances that need to be created. There is a bunch for Alice and some for Bob. So now Aptomi is actually going and creating those instances, right? And in the US West, as well as in the US East. And I want to explain a little bit about what's happening behind the scenes. And the UI is going to help me in this regard. So first of all, let's go here into a thing called desired state. And maybe let me go back to the version 5 where nothing existed. So now there was version 6, right? So when the first command that we did, we're like, OK, let's instantiate this Twitter stats for Alice. Aptomi knows that there is service claim on the Twitter stats. So Aptomi is, OK, like, I need to instantiate Twitter stats in the US West. I need analytics in the US East. So the whole service graph that is triggered by the service claim, you can see here, and it's basically instantiated. And then you can see the version 7 when Bob incrementally asked for Twitter stats. But if I click this button, it says compare with 6. So green one is the net new. Right, so you can see that when Bob incrementally, or dev2, right, they incrementally ask for another version of Twitter stats because the rule says that analytics is shared. You can see that only the Twitter stats thing got created for Bob, right? Analytics is still shared between those two. And let me also trigger the production one, right, the right side of the picture, the production service which actually gets data from Twitter. I'm going to go do it in exactly the same way. If I go to here to instances, you can see that some of the stuff is still being processed. And if I go to the browser, I will be able to see another version which got created. So let me untangle this a little bit. So production is here, and dev are here. So now you can clearly see that there is a production, right? And you can clearly see that there is those two development versions. And production runs in East, development runs in West. So now let's go back to instances. OK, so let me double check. So I can go query the endpoints of all the stuff that got deployed, right? I mean, we can take a look that there is HDFS. It's right here. Spark got deployed as well. And you can see this. This is the endpoint, right, of the Twitter service, which kind of pulls those fake tweets and generates, displays results on the web. So this is dev1. Let me do the dev2 as well. So dev2 is also alive. You can see those. So those development -x, those are the fake tags. And let me show you what's going on with the production right now. So we launched production, but health check for production are not passing yet, right? Because we actually, I mean, the part that connects to Twitter, I haven't provided my Twitter keys yet. So it cannot connect to Twitter. So I think this is a good opportunity for us to actually demonstrate how the service update is going to be handled. And likely you will do this through the GitOps or CLI, but for the purpose of this demo, I'm just going to go in user interface. I'm going to update the keys. So instead of fake keys, I'm going to put my Twitter tokens, which I generated through Twitter API. So I'm going to save this. And here you will be able to see that the old one wasn't able to connect, right? And now Aptomi knows the impact of that change, right? I changed the set of labels. Aptomi knows that none of the services that need to be attached, it knows exactly the impact of this change. It knows exactly that only the Twitter stat service is going to be affected because we know the whole service graph, we know all the dependencies, right? So we're only going to terminate the old one, which was trying to connect to Twitter with the incorrect keys, and we're going to run the other one, which is using good keys, right? So now let's see. Let's try to open the endpoint for production instance. Cool. So you can see that it started pulling some tweets. So before that, it was not available. Now it's actually started pulling some tweets. As the time goes on, it will get more and more information because it's just connected to Twitter probably like a minute ago. Cool. So what's the state right now, right? So right now we have 3 instances running. We have 2 devs running with a fake generator, and we have production running with the real stuff. So this is great, right? But this is not the full story. So what we've shown is we've shown how to define a service, right? We've shown service update, which instantiation and update, and we showed some of the rules, right? How you can control placement. So same way you can control things like security and other things. So you can define the rules, basically saying that if this condition is true, right? It's like if it's a service from a certain label, and maybe you want to have some other label-based condition expressed, then you want to take certain action. And maybe you want to do HTTPS, or you want make it like a call out to an external security system or something like this. So you can take action based on that. So this is all great, but the part that we haven't showed yet is how this would fit into the CD, right? So how you would call this from pipelines and how this would make your life easier. So let's go ahead and do that real quick. I think we still have plenty of time to do so. So the way how we're going to do this is I have concourse right here. So for those of you who have seen the previous presentation, there was Spinnaker. So this is concourse. If I log into concourse, you will be able to see that it's also completely clean. There are no pipelines. And what I'm going to do, I'm going to go ahead and run my script that will create a couple of pipelines in concourse. So I'm going to do this, use my cheat sheet. So what this thing does is it creates a Git repo from where the state is going to be enforced, right? If you run it from Git, you usually have a pipeline, grabs your Git commit, and does something based on that. So it initializes the Git repo and creates a pipeline in concourse, so everything is code, right? I don't have to go to UI and do anything. Now, if we reload concourse, you can see that there is those 3 sample pipelines. So there is one pipeline which deploys a dev version, runs some tests, and then destroys it. In the real life, you're going to have probably more complicated pipeline, right? Like it's get a commit, run something. If it tests pass, maybe promote to production, or ask someone for a manual approval to promote your code to production, things like that. But this is a very simple pipeline in concourse. Or I have also the one-stage pipeline called apply rules, which we can try right now. So what I'm going to do, I'm going to show you that Git repo that just got created. So this is the Git repo. You can see that this initial commit a minute ago. And I can go to the rules, which we can actually change and then propagate through the pipeline. And before I do this, so let me just run the pipeline manually once, just to show you that it's not going to make any changes, right? Because the state that we pushed into Git is exactly the same state as I've been using through the CLI. So when you run the pipeline, what happens is concourse fetches your Git repo, gets all the state from it, and then it runs a certain set of tasks, right? In this particular case, it will pull a container with the Aptomi CTL and run Aptomi from it. So then you can see that once the container gets pulled, it calls Aptomi. Aptomi basically says no changes, right? It's policy version 9, no changes that has to be made. Cool. So it means that the state enforcement from Git actually works. So what we're going to do, and again, maybe it's a little bit artificial case, but you can see that right now all of the services, they run in 2 clusters, right? Like what if we want to move them to 1 cluster? Again, it's maybe a little bit artificial, but maybe you want to change that development hashtag to something else. Maybe you want to update the service definition, but in this case, we're just going to update the rule, right? So those are the rules. I'm going to make them a little bit bigger. You can see that platform services east, real-time services east, dev services west. So what if we want to change that? Let me see. I'm going to click the edit button right here. And I'm going to change that west to east. And see if we can enforce that change. So I commit my changes. So now it basically says all 3 have to go to the US East. And what we're going to do, we're going to go ahead and rerun that pipeline. I have this pipeline set to be triggered manually. I can also have it set to be triggered from a Git commit. But basically, I go to concourse. Pipeline runs, whether you trigger it manually or in the automatic fashion. You can see, so this yellow thing, that means that this stage is running. So if you have a multi-stage pipeline, you'll be able to see that individually for each stage. So then apply rules. So this thing is running. You can look at the log files that Aptomi is actually applying changes. And then see in the Kubernetes, you can see that in the west, all the instances are being terminated, right? And in the east, the instances are being created. So what's happening behind the scenes is because we changed the rule, we do this real-time enforcement, right? So that all of the components, we changed one rule basically saying that if the label is this, then do this. And Aptomi is enforcing that change. It's moving all the instances from one cluster to another cluster. And once this process is done, hopefully it should be done already, I think. Let me go back to, so rules. You can see that config was actually updated from Git. Everything is code. And then if you go to instances, I think the thing, so let's see what we actually got moved. So we got moved the 2 dev instances, right, from the cluster US West. And then we open the endpoints. You can see that they're still alive, right? Just got moved to a different cluster. So same thing as instantiation, we can do deletion as well. So for example, if we go to, I don't know, so let's do the prod, just to show you. Maybe that's the last thing for this demo. So we're going to be taking the prod version. I'm going to go hit delete, do OK. Then you can see that Aptomi, once the change is processed, you will see that the Aptomi will actually start terminating the instances, right? And again, based on the usage, we know that the analytics pipeline should not be terminated because it still has consumers because the other 2 instances are using this. But all the Twitter stuff is going to be cleaned up from the cluster, right? It's super useful, especially if like you have one Kubernetes cluster, you don't know who's using what, why the containers were created, and why they exist, and why they're running, and who belongs to what. So this kind of allows you to track those things down to the individual service claims and who are using what. So now, if we refresh that, you'll see that the production is no longer available. So that's pretty much it. So in terms of the live demo, I think that concludes it, right? So we've seen service composition, rules. We've seen how this integrates into CD pipelines, arbitrary tools, right? It's just Concourse is our preference because it's super lightweight. Spinnaker, Jenkins, no problem. And just to conclude this, that we have a little bit of time left. So just to conclude, what we've shown is we've shown this CD system, which is service-centric, right, that allows you to run multi-container apps across multiple environments, multiple clusters, where components are owned by multiple teams. Again, the focus is services, right? Not individual containers or Helm chart. The focus is composable services and how to run them in an easy way in your organization. And Aptomi, as I said, it's written in Go. It's 2 binaries, so there are no complicated installers. There's no dependency hell. It's just 2 binaries that you can run or on Mac or on Linux. You can install it into Kubernetes as well. It's super easy to try. You just go to our GitHub. You can replicate exactly the same example that I just showed. There are step-by-step instructions on how to do this, whether you want to run on JKE, whether you want to run on Azure, or you want to run on Minikube. You point us to those clusters, then you deploy that example. Super easy to replicate. Or if you want to get started with your own Helm charts and build your own services, this should be doable as well. So I think that concludes it. If you liked it, you're welcome to go check our GitHub. Maybe put a star. We like stars. And then if you need any help, right, if you are seeing similar problems running Helm and Kubernetes, don't hesitate to join our Slack, ask us questions, or email me directly. So we should be able to help. So that's it. All right. Any questions? It's actually cool that the demo worked. It's like everything was pretty smooth. I didn't have to pull like videos or anything. So questions?
You have slides posted?
Slides?
Yep.
So slides, they should be. We don't have slides posted, but we do have a video. Okay. So the video is linked from the GitHub page. If you go to the GitHub page, there is like terminal videos in a schema, as well as the YouTube video. So those are just posted on GitHub. Cool. All right, one more.
Still using like Helm server, like is there still the idea of releases and rollouts and stuff like that in Helm?
So the question was if we're using Helm, right? So I mean, under the hood, we're definitely using Helm because if you've seen service definitions, all that stuff is Helm-based. So we don't interact with the process how you build and publish those Helm charts, but once you have them built and published, we can just point at them saying that, hey, this chart is a part of this service, run it with those parameters, like fixed parameters or dynamic parameters. And when we deploy stuff into Kubernetes clusters, yes, I mean, there is Helm and tiller part, obviously it's there. And if the tiller part is not there, Aptomi is actually going to go ahead and create it automatically in that Kubernetes cluster.
So you can also work with like all the secure Helm, like
Yeah. And then Helm is only one option. If you want to use, for example, Kubernetes YAMLs directly and don't use Helm as a package manager, you can do this as well. Because Helm is a plugin, support for Kubernetes is a plugin, support for Kubernetes YAMLs is a plugin. So everything is super pluggable. Just one more plugin for us.
And on which host do you envision to run this Aptomi server? Is it going to be? Is it going to run inside Kubernetes, alongside of Kubernetes, or like where?
Yes, so that's a very good question. So we support all options. So the question was about where to run the Aptomi server itself. So if you go to the GitHub, you will see a very simple 3-step process. Right. So one is installation of Aptomi, and then you can see there are 2 modes. Right. There is a compact mode. That's the one that I used. You install it on the local host, whether it's binaries or you run it in a Docker container, you run it locally, probably useful if you want to just play with it. Or if you want to run Aptomi itself in Kubernetes, right, with the data stored in the persistent volume, you just follow this link, you just Helm install Aptomi, and you're going to have Aptomi server itself running on Kubernetes.
Thank you.
So as easy as that. Right, so the question was about the dependency graph, right? How we handle those dependency graph between services. So the way how, excuse me, so the way how it's done, when you define a service, right? You define components of the service. You can basically define one component points to one Helm chart, the other components point to another Helm chart, and then you define dependencies between services. So this is done in our language, in our YAML files, but it's super simple. It's just basically a dependency and then a list of dependencies on which other services your service depends on. All right, so 4 seconds left, so I guess that was the last question. So thanks, everyone.